So in part E, we have a third experiment where we are investigating the enthalpy of the reaction between lactic acid and sodium hydroxide. We have student combining a given concentration of lactic acid, a given temperature with NaOH. We're told the final temperature and the density of each solution is the same. We're told the specific capacity of the combined solution. We need to calculate the quantity of heat produced in the reaction in joules. So we can use Q is equal to MCAT. And so this will simply be the mass. So we see that this specific heat capacity is given in joule per gram per Celsius. So what that means for us is that we don't need to convert our grams into kilograms. So we can simply say 200 grams. And then this we will multiply with the specific heat capacity, 4.2. And this will be multiplied with the temperature change. So 23.2 minus 20 will be 3.2, which will give us 2,700 joules. All right, and of course the 200 grams came from the fact that they both have a 1 gram per milliliter solution concentration, and they have a combined volume of 200 milliliters. In part 2, we need to find the molar enthalpy of the reaction. So we can simply say delta H of the reaction will be the Q of the reaction, negative Q of the reaction, divided by the number of moles that reacted. So this will be minus 2,700 divided by the number of moles. And well, we are told that we have 0.1 milliliters, 100 milliliters, so that would be 0.1 liters. And we're told the molarity is 0.5, which just means it's 0.5 moles per liter. So if we multiply these two, we get the total number of moles. So this will be minus 54 kilojoule per mole. And in part 3, we're told student claims that the heat is lost from the calorimeter to the surrounding air during the reaction. And we're told the experimental value of the molar enthalpy of the reaction will be smaller. We need to agree or disagree. And well, we can agree because if we lose energy, so if heat is lost, then that means our final temperature will be smaller. So smaller final temperature, which means that delta T decreases, which will mean that Q decreases, and therefore delta H will also decrease, and therefore the deduction is correct.